Imagine that life on Earth is not a unique miracle born in isolation, but just one of many sprouts that the universe once scattered across different worlds, like a gardener throwing seeds into various corners of a vast, dark garden. If this is so, a strange yet logical question arises. What if someone once did this on purpose? In science, there are two intriguing ideas: panspermia and directed panspermia. The first suggests that life can be transferred between planets randomly via asteroid fragments, cosmic dust, or meteorites. The second adds a far more provocative idea. Life may have been deliberately brought to Earth and other planets by someone more advanced. Not necessarily movie aliens, but a civilization that was many steps ahead of us. In this video, we'll explore the fundamental difference between ordinary panspermia and directed panspermia, the scientific arguments behind these ideas, why some scientists took them seriously while others were extremely skeptical, and, most importantly, what all this could mean for our understanding of our origins and the future of humanity. What is panspermia in simple terms? Let's start with the basics. Panspermia is the hypothesis that life does not necessarily arise from scratch on every planet. Instead, it may travel through space in the form of microscopic organisms, spores, or fragments of DNA hidden inside rocks, ice, or dust, crossing enormous distances and upon reaching favorable conditions, waking up and beginning to evolve again. At first glance, this picture sounds fantastical, but it rests on several important points. Some microorganisms on Earth show astonishing resistance to radiation, vacuum, and extreme temperatures. It is known that powerful asteroid impacts can eject fragments of planetary rock into space. Some of this debris could theoretically land on other planets or moons. In classical panspermia, all of this is viewed as a natural, random process. No one controls it. No one aims deliberately. Space simply does what it does, scattering material, and in some places, life takes root. Now for the most interesting part. Directed panspermia is the idea that the transfer of life might be intentional rather than accidental. In other words, some highly advanced civilization could consciously send capsules containing microorganisms or genetic material into space in order to seed other planets, or at least give them a chance to develop life. Such a civilization could have several possible motivations: a desire to spread life as a value in itself, an attempt to ensure its biological lineage in case of its own extinction, a long-term experiment to observe how life develops under different conditions, an effort to prepare groundwork for future generations, millions or even billions of years later. The key difference between ordinary and directed panspermia is intent. In the first case, nature acts on its own. In the second, a subject appears, one who sets goals, plans, and implements a strategy for seeding life. Why this idea appeared at all? A natural question arises. Where did the idea even come from that someone could have seeded Earth? The answer is twofold. On one hand, scientists studying the origin of life encounter the fact that the earliest steps, the transition from chemistry to biology, appear extremely complex and improbable. Not so improbable as to be impossible, but enough to provoke the thought, what if part of the work had already been done somewhere else? On the other hand, the more we learn about space, the clearer it becomes that there should be a vast number of Earth-like planets in basic parameters. Conditions suitable for life could arise repeatedly in many locations. The age of the universe provides an enormous timescale for experiments on a cosmic level. Against this background, the idea that somewhere a civilization emerged that learned to control biology and send it into space no longer seems so unbelievable. It remains a hypothesis, of course, but one that fits within scientifically grounded speculation. The mechanics. How could life travel through space? To understand how plausible directed panspermia is, we need to consider whether transporting living systems through space is even possible. There are several basic scenarios, such meteorites and asteroids. A powerful impact can eject fragments of rock into space, potentially containing microorganisms. Some of them might theoretically survive the impact, long-term drift through space, and eventual landing on another planet. Comets and icy bodies. Ice, organic molecules, and radiation shielding deep inside make comets potential carriers of life's raw materials. If living material is embedded within them, it may get a chance to make the journey. Cosmic dust and microparticles. On microscopic scales, particles containing biomolecules could circulate through interplanetary or even interstellar space. If they enter a dense atmosphere and decelerate gently, some structures might survive. Deliberate launch of capsules. This is the domain of directed panspermia. A civilization could create special devices, tiny probes or protected containers, that carry resilient microorganisms, are shielded from radiation, extreme temperatures, and mechanical stress, are programmed to enter the atmospheres of potentially habitable planets, or at least pass nearby. Regardless of the scenario, the main problem is survival. Space is an extremely hostile environment. Vacuum, radiation, temperature swings, lack of nutrients, and millions of years of drift. Yet on Earth, organisms have already been found that, in laboratory conditions, show remarkable resistance to vacuum, radiation, freezing, and desiccation. This is not proof of panspermia, but it does demonstrate its fundamental possibility. What modern science says. It's important to clearly separate speculation from what is genuinely discussed at the scientific level. Scientists do not claim that life on Earth definitely came from elsewhere. Panspermia is one possible explanation that does not eliminate the question of how life arose from non-living matter. Simply shifts that moment to another place, and possibly another time. Even if life did arrive from space, we would still need to explain how it originated in the first place. Panspermia solves nothing magically. It just changes the scale of the picture. Directed panspermia goes even further by introducing the idea of intelligence behind the spread of life. Most scientists treat this hypothesis even more cautiously, for a simple reason. There is currently no direct empirical evidence. Nevertheless, the questions it raises are fascinating. Could civilizations that last billions of years undertake long-term projects to seed life? Could this explain certain observed biological features? Is there anything in our biology that could be interpreted as a signature or marker? At present, the answers are, to put it mildly, unclear. And any claims about signatures in DNA without serious analysis easily slide into pseudoscience. Philosophical implications. Children of nature or someone's project. If we even momentarily allow the possibility that life on Earth is part of a vast directed panspermia program, our perspective shifts. Scenario 1. Life, including us, is part of a natural process with no intention behind it. We are a byproduct of physics and chemistry that reach the level of consciousness. No grand plan, only chains of cause and effect. Scenario 2. We are part of someone's project, not in a religious or mystical sense, but simply as the result of actions taken by an older civilization. Just as humanity itself might one day send bioseeds across the cosmos, and somewhere, far away, life and then intelligent beings might arise and wonder about their origins. In both scenarios, the universe remains vast and cold, but humanity's role feels slightly different. In one, we arose by chance. In the other, someone once made a move whose consequences we now embody. How this relates to the search for extraterrestrial life. Interestingly, the hypothesis of panspermia, especially directed panspermia, influences not only philosophy but also practical life search strategies, if life can travel. Then it makes sense to expect traces of life not only on Earth, but on Mars, on icy moons like Europa and Enceladus, and in ancient meteorites. Finding similar biochemistry in multiple locations within the solar system could indicate either a shared origin or spread. If life was deliberately distributed, a seeding civilization might have left clues, unusual objects, signals, or indirect signs of technological activity. In this case, the search for extraterrestrial intelligence, SETI, and similar projects could be broadened beyond radio signals to include traces of ancient directed panspermia efforts. For now, this remains hypothetical territory, but it poses an important question. What should be considered a sign of intelligent intervention, and what is merely a natural process? Scientific skepticism. Why the idea is treated cautiously. Science demands evidence. An idea's beauty and internal logic do not make it true. There are several serious objections. Even the most resilient organisms have limits. Millions of years in space under constant radiation could destroy any complex structure. The probability that a protected microorganism not only reaches another planet but also lands in suitable conditions and gives rise to a successful evolutionary line may be extremely small. So far, there are no unambiguous traces on Earth that require explanation via external seeding. As a result, many researchers view panspermia as an intriguing possibility rather than an established fact. Directed panspermia, in turn, is often treated as an exotic but logically permissible scenario for which no direct evidence yet exists. If humans became seeders of life. To better grasp the idea, let's flip the question. Imagine not abstract aliens, but ourselves, humanity say, 1,000,000 years into the future. Space technologies have advanced to the point where interstellar travel, even if extremely long, is possible at least for automated probes. Biology and genetics have progressed enough to allow us to design resilient, adaptive microorganisms capable of surviving extreme conditions and initiating biological chains on new worlds. Energy resources allow us to launch billions of microcapsules in different directions. In such a situation, humanity faces a choice: remain confined to its own planet and nearby colonies, or attempt what nature does slowly and randomly and deliberately, spread life further. From a human perspective, this project would raise numerous moral, philosophical, and ethical questions. Do we have the right to interfere with potential local ecosystems on other planets? What if life already exists there, even in microbial form? Is spreading Earth's biology a benefit or a form of cosmic pollution? And yet there would also be another feeling. We are expanding the presence of life, turning it from a local phenomenon into a cosmic one. And here the question returns once more. If we may one day do this, who says someone else didn't do it before us? Ethics and cosmic hygiene. In practice, even today, space missions follow strict planetary protection rules. Their purpose is to prevent Earth microorganisms from contaminating potentially habitable worlds, avoid bringing unknown living systems back to Earth without control, In other words, humanity is currently trying not to be an accidental agent of panspermia, at least within official science and space exploration. This shows that the transfer of life is not just a theoretical issue, it is also a practical concern in astronautics. How do we explore other worlds without distorting or destroying whatever might exist there? If a civilization capable of directed panspermia ever existed or exists today, it likely faced similar dilemmas, but on a vastly larger scale. It's important to emphasize, directed panspermia does not negate evolution, physics, or chemistry. It simply proposes an additional layer, intelligence as a participant in cosmic processes, rather than merely their accidental outcome. So, what is the key difference between ordinary and directed panspermia? Ordinary panspermia says, life can travel through space spontaneously, randomly, without a plan. Directed panspermia adds, life may have been launched or scattered by someone capable of controlling matter, energy, and biology at a level we have yet to reach. Science has not yet provided a definitive answer to where life on Earth came from. But the very act of asking such questions shows how profoundly our perception of the universe has changed. From a small stage with a single planet, to a vast cosmic theater where not only natural processes but projects spanning billions of years may be possible. And now, to you. How do you feel about the idea that life on Earth might be part of someone's long-term experiment or project? Do you think humanity should one day spread life across the galaxy if technology allows it? And if so, would that be progress? Or a form of interference for which we might one day be held responsible? Share your thoughts in the comments, send this video to those who enjoy thinking about big questions, and if topics like this interest you, hit subscribe. There are many more stories ahead about how small life tries to understand a vast universe.